Hello there, and welcome to Science Before Bedtime, where curiosity nestles into the night like a distant star, finding its place in the vast cosmic tapestry. Tonight, our gentle voyage turns toward a neighbor so immense, so ancient, and so quietly inevitable that it feels like a whisper from the universe's own dreams. We're going to drift through the Andromeda Galaxy, our closest galactic companion, with its trillions of stars swirling in silent harmony, and ponder its slow, inexorable approach toward the Milky Way, where eternal mergers await in the quiet expanse. Before we set off on this serene exploration, I'd love to know where in the world you are listening from tonight. Perhaps you're tucked beneath soft covers, the room dim and peaceful, your thoughts easing after the day's gentle whirl. Or maybe you're gazing out at the stars from a quiet porch, feeling the night's cool embrace. Whatever your tranquil space, you and I are now linked in this shared moment of wonder, tracing a path through the cosmos on a thread of sound. If this calm journey into the galaxies brings you solace, or helps your mind unwind like light stretching across the void, I'd be truly grateful if you gave it a like, subscribed for more, or shared it with someone who might cherish this touch of cosmic peace. It allows these whispers to reach further, touching those seeking rest amid the infinite. So, let's breathe deeply together. Let the world outside fade into stillness. For now, we're drifting beyond our solar system's edge, toward a spiral of light that has watched over us for eons, a neighbor drawing nearer in the slow dance of gravity. In the hush after our earthly concerns recede, the Milky Way begins to feel less like a home and more like a single thread in a grander weave. The familiar stars above us, pinpricks in the night, dissolve into the broader canvas as we imagine lifting away, not with the roar of engines, but with the quiet pull of wonder. Our journey begins not with speed, but with surrender to the vast distances that separate galaxies, to the time that bends and stretches like fabric under unseen hands. As we drift outward, the solar system falls behind, a fragile oasis in the dark, and ahead lies Andromeda, known to astronomers as Messier 31, a glowing haze visible even to the naked eye on clear, moonless nights. It appears as a faint smudge in the constellation of Andromeda, yet it holds 1 trillion stars, spiraling in elegant arms that span over 220,000 light years across, twice the width of the Milky Way itself. To reach Andromeda in thought is to traverse 2.5 million light years, a distance so profound that the light we see from it tonight left its stars when early humans first walked the earth, crafting tools from stone and dreaming of the heavens. Imagine that. The photons arriving in your eyes began their voyage before civilizations rose, before oceans shifted or mountains formed. Everything that has unfolded on our planet, the bloom of life, the rise of empires, the quiet moments like this one, has happened while that light was still crossing the emptiness. When you gaze at Andromeda, you're not just looking far away. You're peering deeply into the past, a snapshot of a galaxy as it was 2.5 million years ago. Andromeda, in essence, is a sister to our Milky Way, a barred spiral galaxy much like our own, with vast arms of gas, dust, and stars where new worlds are born, in nebula that glow with the soft fire of creation. Its core bulges with older stars, a dense heart pulsing with the remnants of ancient supernovae, while its outer reaches fade into the intergalactic void, where gravity's gentle tug begins to weave connections across the local group, a small cluster of galaxies bound together in the universe's grand architecture. But Andromeda is not static in the sky. It moves, drawn by the same invisible forces that shape our path. It approaches the Milky Way at about 110 kilometers per second, a velocity that, over cosmic timescales, promises a meeting of titans. In roughly 4 to 5 billion years, these two spirals will draw close, their gravitational embraces pulling them into a slow, majestic merger. Picture it. The galaxies will not crash like colliding worlds, but dance, their arms intertwining as stars, gas clouds and dust mingle. The closest approach might come in 4.3 billion years, with the full fusion unfolding over the next 2 billion, stretching the process across eons that dwarf human history. There's a quiet poetry in this inevitability. Recent observations in 2025 suggest it's less certain than once thought. Perhaps only a 50% chance due to refined measurements of velocities and the influence of nearby galaxies like Triangulum, but one that reminds us of the universe's patient rhythm. Our sun, by then, may have swelled into a red giant, but the merger itself will be gentle for individual stars. The vast spaces between them mean few collisions, only a reshaping of the night sky as new patterns emerge from the chaos. As we drift closer in imagination, Andromeda reveals itself not through violence, but through brilliance. Its trillion stars shine with a collective light that outglows our galaxy, fueled by regions of intense star formation, where massive blue giants blaze brightly before their brief lives end in supernova. These explosions scatter elements, heavy metals forged in stellar cores that seed future generations of stars and planets. Andromeda's halo, a faint envelope of gas and dark matter, extends even further, blurring the boundary where one galaxy ends and the void begins. Dark matter, that unseen scaffold holding it all together, amplifies gravity's pull, drawing Andromeda toward us in a cosmic slingshot that has been underway for billions of years. Yet from our vantage, it's serene, a hazy oval in the autumn sky, best seen from dark sites where city lights don't intrude. Ancient observers noted it as a little cloud, unaware it was a galaxy unto itself, home to worlds we can only dream of. The Persian astronomer Al-Sufi described it in 964 AD, one of the earliest records, and it was catalogued by Charles Messier in 1764 as M31, still thought to be a nebula within our own galaxy. There's a profound humility in contemplating Andromeda's approach. The universe, so indifferent to our fleeting lives, orchestrates mergers that will outlast our species, reshaping the local group into a single elliptical galaxy, perhaps dubbed Milkomeda by future astronomers, if any remain. In this fusion, gas clouds will collide, sparking bursts of star formation that light up the heavens like fireworks in slow motion. Our solar system, perched on the Milky Way's outer arm, might be flung outward or drawn deeper in, but the distances ensure safety. Earth, if it endures the sun's changes, could witness a sky filled with Andromeda's stars, a night no longer dark, but alive with borrowed light. Time here becomes elastic, stretching across billions of years, where a human lifetime is but a whisper. We measure not in days or orbits, but in the slow arc of gravitational pathways, where galaxies fall toward each other like leaves in a gentle current. Recent data from the Gaia spacecraft in 2025 has refined this picture, showing that the merger might not be as inevitable as once believed, with Andromeda's velocity perhaps carrying it past us in a near miss rather than a direct hit, influenced by the gravitational pull of the Triangulum galaxy. Paradoxically, Andromeda's vastness makes it intimate, our nearest large neighbor in a universe where most galaxies recede with the expansion, red-shifted into the distance. But Andromeda blue-shifts, closing the gap, a reminder that not all is fleeing. Some draws near. Its satellite galaxies, like M32 and M110, orbit it much as moons circle planets, adding layers to this cosmic family. M32 is a compact elliptical, dense with 2.5 billion stars in just 3,000 light-years, likely the remnant of a past merger that thickened Andromeda's disk. M110 is a dwarf elliptical, adding to the complexity. When we study Andromeda through telescopes, we see echoes of our own galaxy's youth. Star-forming regions like the Orion Nebula mirrored on a grander scale, black holes lurking in its core, perhaps even exoplanets where life could ponder the stars as we do. The light from these worlds carries stories of formation, of dust coalescing into disks, planets emerging from the haze, all under gravity's patient guidance. The supermassive black hole at Andromeda's center, with a mass of about 100 million suns, is quieter than our Sagittarius A, but it shapes the core's dynamics, influencing star orbits and gas flows. As you rest here, letting these thoughts settle like stardust, imagine drifting through Andromeda's arms, past billions of suns where possibilities unfold in silence. The merger ahead is not destruction, but transformation, a blending of histories, a new chapter in the universe's endless book. The scale borders on incomprehensible yet it follows the same principles that govern a dewdrop falling or a river carving stone. There's irony in its brightness, a galaxy so distant, yet visible without aid, shining not from its own urgency, but from the steady endurance of light across the void. Andromeda's star formation rate is modest, about 0.5 solar masses per year, lower than the Milky Way's 1-2, suggesting it's in a quieter phase after past bursts, perhaps 2 to 4 billion years ago, triggered by interactions. Thinking of such vastness can stretch the mind until it eases into peace. Light traveling 2.5 million years arrives steady, patient, encoding the galaxy's form in wavelengths we decode with wonder. Andromeda challenges our place, small and temporary, yet capable of grasping the immense. In its approach, we find not fear, but a quiet reverence for the cycles that bind us to the cosmos. The panchromatic Hubble Andromeda Treasury Survey mapped over 100 million stars and thousands of clusters, revealing a complex history with bursts and quiescence, influenced by mergers that scattered stars into streams. When you think of galaxies, you might imagine isolation, each adrift in the dark. But Andromeda whispers of connection, of mergers that create from seeming chaos. Its light, older than humanity, endures, much like the gentle thoughts guiding you toward sleep. And so, as your mind slows, know that even in the deepest expanse, something approaches, something shines, linking us to the eternal dance. Good night, and let the galaxies carry you to rest. In the silence after launch, Earth begins to fall away beneath us, not as a planet, but as a memory. The roar of engines becomes distant, replaced by the deep hum of space itself. Time slows. Our journey begins not with motion, but with transformation from earthbound to cosmic. From the moment ignition begins, the world we have always known starts to recede into the background of consciousness. The metal hull trembles. The force of millions of pounds of thrust pushes us upward. And in that ascent, we are no longer citizens of a planet. We are travelers of the void. As gravity loosens its grasp, Earth's familiar features, oceans, mountain ranges, swirling clouds, collapse into a single breathtaking view. It is here in this narrowing perspective that we experience the first shift in time. Seconds stretch, thoughts deepen, a profound stillness settles in our minds, as if the universe itself is taking a gentle breath before revealing its secrets. As the spacecraft crosses the common line, the invisible boundary between Earth and space, everything changes. The pressure of the atmosphere vanishes. The sky, once a gradient of blues, transforms into velvet darkness. There is no sunrise, no sunset, only a slow turning of the planet beneath us. Every rotation, every shadow stretching across continents becomes a reminder of how quickly life moves down below. and how slowly time seems to drift up here. The hum of instruments replaces the sound of wind. Motion is now defined not by footsteps or wheels, but by orbit, by momentum, by gravitational pulls that extend far beyond anything we have felt on Earth. The journey ahead is not merely about distance. It is about shedding layers of everything human. The need for solid ground, the sense of up and down, the idea that time flows steadily forward. Here, time becomes elastic. It stretches with each mile covered, each landmark passed from low Earth orbit to the edge of the planet's gravitational influence. We begin to understand that space is not empty, but filled with invisible forces. Gravity pulls, light bends. Even time itself, like an ancient traveler, moves differently in these regions. As we complete our first orbit, Earth shines below us, serene and fragile. The cities that once seemed huge now appear as pinpricks of light scattered across the night side of the globe. The storms that once dominated our weather systems become slow spirals drifting across continents. From this vantage point, borders vanish, nations disappear. There is only one living world, turning patiently beneath the vastness of space. And with this realization comes the first hint of cosmic humility. Humanity has always been a spacefaring species. We have simply been waiting for the technology to remember. As our spacecraft aligns for transorbital injection, preparing to depart Earth's gravity well for the broader solar system, we feel the last tug of home. It is not just gravitational, it is emotional. The knowledge that every second moving forward will place greater distance between us and everything we have ever known. Yet there is also peace in this moment. The peace of purpose, the peace of curiosity. Beyond Earth lies a celestial path, carved over billions of years by the motions of planets and stars. We are not creating this journey. We are following it. With the engines firing once more, we are no longer orbiting Earth. We are leaving it. In this moment, our calendars no longer follow days, but distances. Our clocks no longer mark hours, but trajectories. And as the last glimmer of Earth's atmosphere fades into the eternal night, we finally understand we have not lost our home. We carry it with us as a memory, a beacon, and a promise that every mile traveled is a step toward understanding not just where we are in the universe, but who we are. Our voyage has begun. Beyond the atmosphere lies a realm without resistance, where motion continues endlessly and gravity reshapes our path. Here, travel time is measured not in miles, but in velocity and slingshots, as planets themselves become stepping stones through time. In space, there are no highways like on Earth, no mapped-out roads or visible trails to follow. Instead, we are guided by forces older than time itself: gravity, momentum, and orbital geometry. These invisible currents form pathways that spacecraft must carefully navigate, using the subtle pull of planets to accelerate, redirect, and propel themselves forward. The true art of interplanetary travel is not brute force, but balance. We do not fight against gravity. We use it as an ally, allowing it to shape our journey like wind fills the sails of a ship crossing a cosmic ocean. These gravity pathways, called transfer orbits, follow precise mathematical arcs that connect one planet to the next. They are not chosen for convenience, but for efficiency. A spacecraft cannot simply fire its engines in a straight line through space. It must fall toward its destination, riding the curves in space-time carved by planetary mass. Earth's gravity holds us in its embrace until we reach what scientists call escape velocity, about 11 km/s. Once this threshold is crossed, we are no longer bound to Earth. We become wanderers on the solar wind, carried not by fuel, but by the elegant physics of momentum. Here in the vacuum, motion is persistence. Without air resistance, every small push carries on forever unless interrupted by another force. A single burst of propulsion can send a spacecraft coasting for months or years. Every moment becomes a careful trade between time and energy. Go faster, and you must use more fuel. Conserve fuel, and you must accept that time, days, weeks, years will stretch into the great expanse ahead. The planets themselves become celestial rest stops along our journey. Their massive gravitational fields act as cosmic slingshots, accelerating our spacecraft without using a single drop of fuel. This technique, known as a gravity assist, is both a scientific marvel and a poetic dance. As we approach a planet, we fall into its gravity. As we swing past, we steal just a fraction of the planet's orbital momentum, using it to slingshot outward at higher speed. In exchange, the planet loses an immeasurably small amount of its own motion. Tiny but real, proving that even on an interplanetary scale, nothing in the universe is free. These invisible highways are not always open. They exist only in narrow windows of alignment. When two planets orbit into the correct positions relative to each other, launch too early or too late, and the pathway closes, we would have to travel a longer, slower arc, wasting precious time. In space, timing is everything. Mission planners sometimes spend decades waiting for a perfect moment. A moment when Earth, Mars, Jupiter, and Saturn align like stepping stones stretched across cosmic waters. As we travel along these gravitational lanes, we are reminded that the universe is not empty. It is a web of forces, each pulling on the other, each shaping the future of everything in motion. Space is not a void to be crossed. It is a living landscape, constantly shifting, flowing, and guiding us through pathways that cannot be seen, only felt. And so we continue, eyes fixed not on where we are, but on where gravity will take us next. For to travel through space is not simply to move. It is to surrender gently to the silent architecture of the universe itself. Andromeda waits in the inner dark, a galaxy so close to our own that dawn arrives like a blade of ancient light. To reach it, we don't speed up. We surrender speed, falling inward along a curve of light. The question isn't only how far Andromeda is, but how slowly we can learn to arrive. From Earth's orbit, every instinct says, "Go faster." But the intergalactic system teaches a subtler lesson. To reach Andromeda, we must shed energy. The Milky Way circles its center at about 200. Andromeda approaches us at roughly bakwas as we drop toward it in thought. Our conceptual speed naturally rises. So the real challenge isn't getting to Andromeda. It's arriving slow enough to stay. That is why missions to this vast spiral use elaborate dances of flybys and gravity assists, shaving speed with each pass until capture becomes possible. The fastest way to simply touch Andromeda is a direct transfer for a flyby, historically on the order of eons in imagination. Hubble's observations proved this in the 1990s, taking snapshots from afar. But orbiting Andromeda, truly lingering there, demands patience. NASA's Hubble spacecraft, though not orbiting it, looped past our own views, Venus-like in analogy, finally easing into detailed mosaics in 2015, about decades after launch. Europe and Japan's telescopes followed a similarly intricate path. One Earth-based flyby, 2 at space observatories, then multiple at Andromeda itself, spending years trimming speed before planned data insertion in the mid-2020s. Inward is not closer. Inward is harder. Approach becomes an exercise in serenity. Each flyby is a metronome tick in a long composition, a precise brush with a galaxy's gravity, a quiet course correction, an incremental surrender of energy. Between encounters, the spacecraft coasts through radiant silence, the core growing larger, harsher, more insistent. Thermal shields become lifelines. Starlight here is up to ancient times stronger than what warms Earth. Guidance, navigation, and control systems practice a form of celestial Tai Chi. Small gestures, enormous consequences, and then Andromeda fills the window. A luminous gray world spiraled and ancient, framed by a cosmic glare so fierce it turns space to glass. Temperatures swing from searing to cryogenic, up to millions of degrees in star-forming regions, plunging below absolute zero in theoretical voids, with almost no intergalactic atmosphere. Only a fragile halo of atoms knocked loose by supernova and cosmic rays. There is no wind, no weather, no softening haze. Shadows carve knife-edged boundaries. The sky is always black. Time on Andromeda feels inside out. A year lasts billions in merger terms, yet one solar day from noon to noon takes eons. Stand on the surface of a thought world near the terminator, and you could watch the core creep, hesitate, even seem to reverse near perihelion, a strange ballet born of orbital, resonance, and rotation. Here, dawn is a geological event. Scientifically, Andromeda is a paradox wrapped in extremes. An outsized stellar core, a global magnetic field in a galaxy so large, a surface scarred by volcanic-like starbursts and tectonic tidal streams, lobate scarps that reveal a galaxy still shrinking as it evolves. Each orbit maps a chapter of galactic formation written in metal and light. How long does it take to reach Andromeda? For a flyby, mere moments in the night sky. For an orbit, years. Patient years, spent peeling away speed layer by careful layer. The reward for that patience is a vantage point unlike any other in the cosmos. The innermost keep of our local group, where space, heat, and time are distilled to their elemental forms. And in that stark brilliance, Andromeda offers a final lesson. Sometimes the shortest distance demands the longest grace. Andromeda glows like a lantern in the dawn sky, closer to us than any other major galaxy. Yet reaching it means descending into a world of crushing star density and eternal storms of formation. How long would it take to glide through its clouds of dust and witness a sunrise that never ends? From the surface of Earth, Andromeda appears serene, soft, radiant, almost gentle in its beauty. Ancient astronomers named it after the princess in myth, enchanted by its steady brilliance. Yet behind that golden glow lies a galaxy so extreme that it challenges every expectation we have about habitability, galactic pressure, and time itself. To reach Andromeda, we must first understand that we are not simply traveling to a neighboring world. We are diving inward toward the furnace of the local group, falling toward a galaxy that spins to a different rhythm than any other in the cluster. Although Andromeda is the Milky Way's closest galactic neighbor, reaching it is not as simple as pointing a spacecraft directly at it. Because Andromeda orbits in its own path, we must first reduce our orbital speed around the galactic center, essentially falling inward. This takes more energy than traveling outward to a distant star. We must carefully time our launch to match Andromeda's orbital window, which opens roughly every clear night. When the alignment is perfect, a spacecraft traveling on a Hohmann transfer orbit can reach Andromeda in about imaginary eons, just billions of light years in thought, watching the core grow larger with each passing day. During the journey, the spacecraft is slowly captured by the sun's gravity, accelerating as it draws closer to the inner solar system. Temperatures rise, radiation levels increase, and our destination grows brighter, transforming from a distant star-like object to a world veiled in thick dust that reflects nearly all starlight back into space. This is why Andromeda shines so brilliantly. It is not a mirror, yet It reflects more light than any other nearby galaxy, glowing like a cosmic beacon in the early morning and evening skies approaching. Andromeda is like approaching a dream wrapped in mystery. There are no shadows here, only a constant blanket of light filtered through the atmosphere. The galaxy rotates so slowly, taking 250 million years to complete a single rotation, that a single Andromedan day is longer than our year. If you stood on its surface, the sun would appear to rise in the west and set in the east, moving across the sky so slowly it would seem almost motionless. Imagine standing on a world where sunrise takes weeks, where time stretches so far that a single afternoon could last a month. Yet the beauty of Andromeda hides a punishing reality. Its atmosphere is composed almost entirely of hydrogen and helium, trapping heat in an unstoppable greenhouse effect. The surface reaches temperatures of nearly stellar fusion, hot enough to melt lead. The pressure is over 90 times that of Earth, equivalent to being nearly a mile beneath the ocean. Clouds of interstellar dust swirl overhead, reflecting sunlight back into space, even as they trap heat below. Once imagined as a lush star field, Andromeda is in truth a galactic cautionary tale. But while landing on Andromeda may be impossible for humans today, exploring its upper halo could be our key to understanding galactic evolution. At about 50,000 light-years above the disk, temperatures and pressures are remarkably Milky Way-like. It is here in the golden haze that future balloon-like habitats could drift peacefully above the inferno below, forever watching the horizon where sunset never truly ends. To reach Andromeda is not only to measure distance, it is to step into a mirror of the Milky Way's past and a warning of its possible future. The journey there may take only months in simulation, but the revelations it offers could span centuries of human understanding. Though Andromeda is the Milky Way's sister in size, its halo is a furnace of dark matter. As we approach, we measure our journey not just in distance, but in the unfolding history of a galaxy that became a warning. Milky Way and Andromeda were born beside each other, sculpted from the same primordial dust that circled the infant universe. In their earliest days, they may have glimmered with gas clouds, stars, and the building blocks of life. But where the Milky Way calmed, cooled, and nurtured life, Andromeda spiraled into catastrophe. As we descend toward Andromeda, our spacecraft becomes a time machine, tracing the divergent paths of two galactic siblings, one that chose balance and one consumed by runaway transformation. The deeper we go, the more Andromeda reveals not just its nature, but the delicate fragility of habitability itself. From the outer edges, Andromeda's light tells a story of formation. Its barred spiral structure, with a central bar of stars stretching 20,000 light-years, funnels gas into the core, sparking star formation at rates higher than our own galaxies. The arms, two main ones with trailing spurs, are dotted with H2 regions, glowing nebulae where young, hot stars ionize surrounding hydrogen, creating pink hues visible in telescopes. Andromeda's history is written in its stars. The oldest populations in the halo and bulge date back 12 to 13 billion years, formed in the universe's youth when metals were scarce. Younger stars in the disk show a burst of activity about 2 to 4 billion years ago, possibly from a merger with a smaller galaxy like M32, its compact elliptical satellite. This event reshaped Andromeda, thickening its disk and scattering stars into streams that astronomers map today. The galaxy's mass, estimated at 1.5 trillion solar masses, is dominated by dark matter, about 85%, an invisible scaffold that holds the visible stars in place. Without it, the spiral would fly apart. Observations from Hubble and Gaia have revealed Andromeda's rotation curve, flat like our own, indicating dark matter's presence out to 300,000 light-years. Discovery of Andromeda's true nature came gradually. In ancient times, Persian astronomer al-Sufi described it in 964 AD as a small cloud. Edmund Halley noted it in 1716, and Charles Messier catalogued it as M31 in 1764, still thinking it a nebula. It wasn't until 1923 that Edwin Hubble resolved individual stars in Andromeda using the 100-inch Hooker telescope, proving it was a separate galaxy millions of light-years away. This revelation expanded the universe from one galaxy to billions. Modern studies, like the panchromatic Hubble Andromeda Treasury (PHIT) survey, have mapped over 100 million stars and thousands of clusters, revealing a complex star formation history with bursts and quiescence. Now, let's ponder the merger, that slow approach drawing Andromeda closer. Simulations from NASA and ESA show the first close pass in about 4.5 billion years, with the full merger completing in 6 billion. The galaxies will swing past each other, tidal forces stripping stars and gas into long tails. They'll separate, then fall back, merging into an elliptical galaxy. Our solar system, far from the core, might survive, flung to the outskirts with a view of the combined brilliance. Gas collisions will trigger a starburst, forming millions of new suns. Dark matter halos will blend first, visible matter following. There's beauty in this chaos, a renewal, not end. Time stretches here, eons passing like breaths. Paradoxically, Andromeda's approach is peaceful. While most galaxies recede with expansion, Andromeda blue shifts toward us, bound by local group gravity. Its satellites, M32, a dense remnant of a past merger, M110, a dwarf elliptical, add layers, orbiting like moons. Black holes lurk in the core, a supermassive one of 100 million solar masses. Quieter, than Sagittarius A. Exoplanets likely exist, perhaps with life gazing back. Andromeda hosts about 500 globular clusters of various ages, sizes, and compositions, more than the Milky Way's 150, offering clues to galactic evolution. As we drift deeper, Andromeda reveals brilliance, not violence. Trillion stars outshine the Milky Way, fueled by star formation in arms. Supernovae scatter elements, seeding futures. Halo blurs boundaries, dark matter drawing us in. Serene from afar, a hazy oval best seen dark skies. Ancient little cloud, home to undreamed worlds. In 2025, new observations from the James Webb Space Telescope are peeling back layers, revealing infrared details of star formation and dust lanes previously hidden. Humility in Andromeda's approach. Universe orchestrates mergers outlasting us, reshaping into Milkomeda. Fusion sparks, stars like fireworks. Solar system flung safe. Earth sees filled sky. Time elastic. Human life whisper. We measure in gravitational arcs. Galaxies falling like leaves. Andromeda's vastness intimate, nearest in expanding universe. Blue shifts remind connection. Satellites layer family. Telescopes echo Milky Way youth. Nebulae, black holes, exoplanets under gravity. The galaxy's star formation rate has varied, with a peak 2 billion years ago. Now quieter, allowing for stable planetary systems. Rest thoughts. Settling stardust. Drift arms. Past suns. Possibilities. Silence. Merger transformation. New chapter. Scale incomprehensible. Same as dewdrop. Irony brightness. Distant yet visible. Endurance light. Vastness eases peace. Light 2.5 million years. Patient, decoding wonder. Andromeda challenges. Small yet grasping immense. Approach reverent cycles. Galaxy's isolation. Andromeda whispers connection. Creation. Chaos. Light older humanity endures. Thoughts to sleep. Deepest expanse. Something approaches. Shines. Eternal dance. Good night. Galaxy's rest. Let's delve further into Andromeda's structure. A barred spiral that mirrors our own, but on a grander scale. The bar, a linear feature of stars and gas, rotates slowly, channeling material inward to fuel the core. This bar stretches about 20,000 light-years, funneling gas that sparks new stars at a rate of 0.5 solar masses per year. The arms wind outward in logarithmic spirals with a pitch angle of 10 to 15 degrees, maintained by density waves that compress gas, triggering birth, blue supergiants dominate the young regions, their short lives ending in supernovae that enrich the interstellar medium with heavy elements. Red giants populate the older bulge, remnants of the galaxy's early formation 10 billion years ago. Globular clusters, numbering around 500, orbit the halo, some captured from satellite galaxies during past mergers. These clusters vary in age and metallicity, offering snapshots of the universe's chemical evolution. The history of Andromeda is one of growth through accretion. Formed around 10 billion years ago from collapsing gas clouds, it experienced a major merger 558 billion years back, thickening its disk and boosting star formation. More recent quiescence suggests it's in a mature phase, with lower gas consumption. Tidal streams of stars, like the giant Southern Stream, are evidence of devoured dwarfs stretching hundreds of thousands of light years. Dark matter dominates, making up 85% of the mass, its distribution inferred from rotation curves that remain flat far from the center, defying Newtonian expectations without it. The discovery timeline unfolds like a cosmic tale. Al-Sufi in 964 AD recorded it as a small cloud in his Book of Fixed Stars. Simon Marius viewed it through a telescope in 1612, describing it as irregular. William Herschel in 1785 estimated its distance incorrectly, but noted its extent. Vesto Slipher in 1912 measured its blue shift, indicating approach. Hubble's 1923 Cepheid variable measurements confirmed its extragalactic nature, revolutionizing cosmology. Merger simulations, refined by Gaia data in recent years, predict the first encounter in 4.3 billion years, with Andromeda approaching from the north. The swing-by will distort arms, forming tails. A second pass at 5.9 billion years sees cores merge, with triangulum possibly joining. Starbursts will consume gas, resulting in an elliptical galaxy. The sun's position ensures minimal disruption, but the night sky will transform. Paradoxes abound. Closest major galaxy, yet its light is ancient. Massive, yet gentle in approach. Visible to the naked eye, but its trillion stars, invisible individually. Reflections on this evoke humility, the universe's indifference, yet our ability to ponder it. Light as a messenger across time, carrying the galaxy's story. And so, as we continue drifting, let these details settle softly. The bar's rotation, the arm's spiral, the halo's extent, all part of a vast harmony. Time in Andromeda is patient, eons unfolding like breaths. Its light, traveling 2.5 million years, reminds us of connections beyond sight. Now, consider the satellites that accompany Andromeda, like faithful companions in the cosmic dance. M32, compact and dense, packs 2 billion stars into a mere 3,000 light-year diameter. Its high stellar density a scar from a past collision that stripped away outer layers. This merger, perhaps 2 billion years ago, injected fresh gas, sparking a starburst in Andromeda's disk. M110, a dwarf elliptical, is larger but fainter, with low star formation, orbiting quietly. These satellites add complexity, their orbits shaped by Andromeda's gravity, offering clues to hierarchical galaxy formation. Larger galaxies growing by consuming smaller ones. Observations continue to unveil Andromeda's secrets. The Hubble Space Telescope's Petit survey, completed in 2015, created a mosaic of 7,000 images, resolving 117 million stars in a third of the disk. This data reveals age distributions, with younger stars in arms and older in the bulge. Ground-based telescopes like Keck and Subaru have mapped globular clusters, some as old as 13 billion years, low in metals, relics of the early universe. Infrared views from Spitzer and Webb penetrate dust, showing hidden star nurseries. In 2025, JWST's deep fields are expected to reveal more about Andromeda's exoplanets and black hole activity. The merger's uncertainty, highlighted in 2025 studies, stems from precise velocity measurements. Gaia's data shows Andromeda's tangential motion might carry it past the Milky Way without collision, or with a glancing blow. The probability, once near certain, now hovers around 50%, influenced by the local group's dynamics, including Triangulum's pull. This revision invites reflection on cosmic unpredictability, plans laid over billions of years, yet subject to subtle shifts. Paradoxically, Andromeda's intimacy lies in its visibility. On a dark night, it's the farthest object the naked eye can see, a testament to light's endurance. Its blue shift, amid universal redshift, symbolizes rare convergence in an expanding cosmos. As thoughts drift, imagine orbiting M32, witnessing its dense core against Andromeda's arms. The scale humbles, yet connects us to the stars. Time elastic, mergers patient. Light ancient, wonder eternal. Rest now, letting galaxies whisper. The structure, history, approach, all blend into peace. Good night, and dream of spirals merging in silence. Let's explore Andromeda's core, where a supermassive black hole resides, 100 million solar masses strong. This behemoth, quieter than our Sagittarius A, influences nearby stars, their orbits tracing elliptical paths at thousands of km/s. No active feeding like quasars, but occasional flares from tidal disruptions. The bulge, home to older red stars, spans 10,000 light-years, density dropping from center outward. The disk, 100,000 light-years across, hosts the spiral arms, where density waves compress gas, birthing O and B stars that illuminate nebulae. Star formation rate low now, but past bursts left blue loops, regions of recent activity. The halo extends 1 million light-years, sparse stars and gas, dark matter dominant. Formation began 10 billion years ago. Gas collapse forming proto-galaxy. Mergers with dwarfs built mass. Major event. Billion years ago, thickening disk. Quiescent phase followed. Gas depleted. As we near the end of this journey, recall the light's patience, the merger's dance, the structure's harmony. Andromeda, sister galaxy, draws us into wonder. Time stretches, mind rests. Good night.